Okay, hello, welcome to my channel. Now in this video, we're going to learn how to differentiate the natural logarithmic function, right? Good. Okay, so here with me is McKay, right? McKay, say hi. Okay, good. Great. And now we have that the natural logarithmic function is of the form y equals to logarithm of x to base e, all right? So this base e here is a natural number which is approximately 2.718, all right? Is the reason why we call this the natural logarithmic function. Good. Actually, this here is an irrational number, right? The decimal part does not terminate and it does not repeat. It just goes on like that. But anyway, let's see. This a function, okay, we denoted with y equals the logarithm of x to base e is commonly written as ln x, right? This ln tells us natural logarithm of x. So this ln x is the same thing as logarithm of x to base e. Good. And now when we differentiate that function, what we enter is the derivative with respect to x of the logarithm of x to base e, right? Which is the same thing as saying the derivative with respect to x of ln x, right? Or we can call it natural logarithm of x, just in place of this, since the two notations mean the same thing. And when we differentiate that, what we're just going to have is 1 over that x, all right? So if we have ln of something, okay, of x in this case, the derivative is just going to be 1 over that x. Good. Okay, so what we'll be doing in this video is to go ahead and prove that whenever we have a function such as this, its derivative will just be 1 over that, all right? Good. So I'm just going to do a proof here. Anyway, this proof is not going to be a real standard kind of proof where I have to use the first principle. I'm just going to use some exponent rules and some logarithmic rules to show you this, all right? So let's put down the function, prove that, okay? So let's say let y be the logarithm of the function x to base e, all right? Good. Now from exponent rules and these logarithmic rules, now that we have the logarithm of x to base e, all right, I can rewrite this in terms of indices, all right? I put this e to power y, that will give us x, all right? So that means that e raised to power y is equal to x just by some logarithmic rules. Good. And then from here, now, take note, our goal is to find the derivative of this function with respect to x, all right? Good. That is to say, we have to find the y dx. So what I'll be doing here is to start off by rewriting this equation such as x equals to e to power y. And then from here, we're going to have to differentiate this function with respect to y, all right? So I'm going to put down the derivative with respect to y. Now this is x, it is written in terms of y, all right? So I'm going to differentiate the function x with respect to y, keeping in mind that what we actually want is the derivative of y with respect to x. So we'll see how we'll get to it. Good. So I'm going to differentiate this x, all right? And that will give us the derivative with respect to y of e to power y, all right? Good. And then this right here is the x dy. So I'm just going to put down the x dy, right? And then I'm going to put it to be equal to, well, when we have an exponential function like this, for example, e to power x, the derivative of e raised to power x with respect to x is just that e to power x, all right? Now that we have to differentiate e to power y with respect to y, we just keep the function without changing anything, all right? So we just the same thing, we just keep down e to power y. Good. Okay, great. And now, since our main aim here is to find the derivative of y with respect to x, but what we have here is the reciprocal of what we want to find. So what we'll have to do is to take the reciprocal of both sides, all right? So from here, we're going to enter with, we put this one on the top and put this one at the bottom, all right? Note that this is divided by 1. So that will become the y, the x is, we will do the same thing to the right-hand side, put the 1 at the top and put the numerator at the bottom, all right? That will become 1 over e to power y. And now we have the derivative of y with respect to x, where y is the function itself. Good. Okay, so let me put down the notation one more time. We have 1 over e to power y. Well, from this equation, maybe I call this equation 1, e to power y is equal to x, all right? Since we are looking for the derivative of the function y with respect to x, we always write the result in terms of x, all right? So we want to replace this term in terms of y to something in terms of x, which is gotten from equation 1. So in place of e to power y in the denominator, I'm just going to put down x. Good. So we're going to enter with 1 over x, right? Okay, so this right here is the derivative of that function with respect to x. So maybe I can write it this way, that the derivative with respect to x of the function natural logarithm of x is just 1 over x. Good. Okay, let me give a little note here. Now, in general, all right, when we have a function, let's say y, to be the natural logarithm of some function of x, all right, so I'm going to put down here g of x, where the g of x could be any function of x, all right, then the derivative of that function with respect to x is going to be, well, what we'll enter with is, when we have natural logarithm of something, differentiating that, we'll have 1 over that thing, right? We'll have 1 over that thing, which is just g of x here. But we are not done. We're going to have to multiply it with the derivative of that inside, right? Using the chain rule. So you differentiate the outside of a thing. We have logarithm of something. The derivative of that will give us 1 over that thing. But here we're going to have to multiply it with the derivative of the inside, all right? So we differentiate this g of x, all right? So we're going to have to multiply it with the derivative with respect to x of g of x. Okay, good. All right. In our next video, we'll be solving examples on functions. We'll be finding the derivative of functions that will be of this form, all right? So that we just apply this rule. Okay, great. All right. Thanks for watching. Please subscribe to my channel.